In this video lecture, we are going to discuss about a FIFO page replacement algorithm. So what is FIFO page replacement algorithm? So this is the simplest page replacement algorithm. FIFO is nothing but first in first out page replacement algorithm. So the definition for FIFO replacement algorithm is a FIFO replacement algorithm associates with each page the time when that page was brought into memory. When a page must be replaced, the oldest page is chosen for replacement. So this is the definition given for FIFO page replacement algorithm. In order to understand it better, here I have brought you an example. So here this is the page reference string, and here the page frame size is given as 3. By looking at the blocks, you can able to see the page frame size is 3. So what is before? The page which comes first will be replaced first. So here the first page to be referenced is page number 7. So initially all the frames are empty. Initially all 3 frames are empty. So in the main memory there is no page loaded. So we want to load page number 7. So page fault happens and it finds the page available in the backing store and it brings the page into the main memory. So there is a page fault because when we want to refer page number 7, the page number 7 is not there in the memory. We find the page in the secondary storage and we brought the page into the memory. Because of page fault, we found that page in the backing store and we bring in the page. Next, it is 0, page number 0, and there is an empty frame. So we load the page number 0 into the memory. And we have to load a page number 1. Still there is one free frame available. So we load the page number 1 in the free frame available. So now you can see it is 701. All frames are filled. There is no empty frame. Next we have to load page number 2. There is no empty free frame available. So among the pages loaded, we have to replace one page. According to FIFO page replacement algorithm, the page which is loaded first will be replaced first. The page which is loaded first is the page number 7. So we replace page number 7 and we load page number 2 in the place of 7. Next we have to load page number 0, and page number 0 is already loaded in the memory. So you no need to replace any of the page because the page is already there in the main memory. So there is no page fault. So there is no page fault for page number 0 at this point. And now we have to load page number 3. Page number 3 is not there in the memory and all the frames are filled. So we have to replace one page so that new page 3 can be loaded. So now our memory is loaded with the page number 201. Among these 3 pages, 0 is the oldest page. 0 is the oldest page. So we choose 0 to be replaced. So in the place of 0, we load page number 3. Now in memory we have pages 2, 3, 1. The next page to be referenced is 0 and all the frames are filled up. So you need to replace a page in order to load a page number 0. Among the pages available, that is 2, 3, 1. 1 is the oldest page. So we choose 1 for replacing. So in the place of 1, we load page number 0. Now we have to load page number 4. And all frames are, and there is no empty frame. So we have to replace a page. So among the pages 2, 3, 0, 2 is the oldest page. So we replace 2 with 4. So now we have 4, 3, 0. The next page we have to load is page number 2. Page number 2 is already not there in the memory and all the frames are filled up. So you have to choose a page for replacement. And we find that 3 is the oldest page. So we replace 3 with 2. And the next page we have to load is 3. So 3 is not already loaded in the memory. So you have to choose a frame for a page for replacement. We find 0 is the oldest page. So we replace 0 with 3. And next we have to load page number 0. So 0 is already not there in the memory. The oldest page among 4 to 3 is 4. So we replace 4 with 0. The next page to be replaced, the next page to be loaded is 3. 3 is already there in the memory. So you no need to reload it again. So there is no page fault here. And next page to be referenced is page number 2. Page number 2 is also there in the memory. So you no need to reload it again. So there is no page fault here also. The next page we have to replace is 1. The next page we have to replace. The next page we have to load is page number 1. So among 0 to 3, the oldest page is 2. So we replace 2 with 1. And next page to be loaded is page number 2. Among 0, 1, 3, 3 is the oldest page. So we replace 3 with 2. And we have to load page number 0. Page number 0 is already loaded. No need to reload it. There is no page fault here. And again we have to load page number 1. Page number 1 is already loaded in the memory. You no need to reload it again. So there is no page fault here also. The next page we have to load is 7. 7 is already not loaded in the memory. So you have to choose one page for replacing. So here 0 is considered to be the oldest page. So 0 has to be replaced with the 7. So now we have 7, 1 and 2. The next page to be loaded is 0 and 1 is the oldest page. So we replace 1 with 0. So now we have 7, 0, 2. The next page we have to load is page number 1. Page number 1 is not there in the memory. So there is a page fault. We have to load page number 1 into the memory and we find that 2 is the oldest page. So we replace 2 with 1. So this is how the algorithm works. So now you can calculate the number of page faults. Here the number of page faults is 15. So you can simply calculate this as by counting these blocks that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So number of page faults happened all together is 15. So this is all about FIFO page replacement algorithm. Thank you so much.